everyone, and welcome back to CSCI 210. Today we'll talk about combining the various control structures that you've already learned about. You've learned about decision structures, if statements that allow you to control the direction of a program based on data or supplied values. You've also learned about iteration structures that allow you to repeat steps as necessary. Now, in a typical program, you may have thousands to hundreds of thousands of instructions, and you may have all sorts of combinations of if loops, while loops, and everything in between. This week's objectives will talk about combining control structures, and this is in preparation for your final project. Okay, I have here a picture of a stick shift to remind us that just because things are simple when you study them separately, that does not mean they're simple when you put them together. For example, I learned to drive on a stick shift car because that's what we learned to drive on back then. And I actually did pretty well with starting up and stopping on a straight and level. Separately, I learned to do pretty well on turning. However, my first intersection after I got my license was uphill, and I had to make a right-hand turn uphill on a stick shift. So I had to make sure that I let out enough clutch and all that so I didn't stall it out. I didn't roll backwards, and also that I made sure that I turned within the lanes. Wasn't so simple when you put everything together. Okay, how to write a complex program. I almost called this how to write a normal program. Most programs are complex. If they were simple, you wouldn't want a computer to do it for you. Okay, and you basically have the steps of plan, build, and test. I'll note parenthetically, build also includes test because you test as you go. Okay, to plan, you need to know what you are trying to do. You need to know the task, and you need to know why you're trying to do it. Then you model the process because most computer programs, you're trying to model some process and do it on the computer where it's supposed to be easier. The other thing, manage the projects. Time management is the most important thing because that's the one patently non-renewable resource you have. Okay, as you build your program, you build it in increments and you test each one of them as you go. I remember one time I had a very complex server I had to build, and I didn't build it in batches. I tried to get it all done at once. Well, I was there for 26 hours, and I had to come back for another 12 hours. That was a miserable couple of days. Okay, you notice that you have tests as you go and build, and you turn around and test again. Why do you do that? Well, you do that because the final test, you kind of back off and look at the whole process and make sure that you're modeling what you need to model. And make sure the program actually meets the objectives. It may run fine and each of the little steps may work fine, but if it doesn't meet the objectives that you originally wrote it for, it's kind of useless. Okay, I've got a sample program that I will build, and I'm showing how each of these steps apply to it. The sample program is, I've noted that when I download a program to the Lightning, it starts right away. I would like to have it where I can start and stop it with the remote. So, and what will happen is this is what I will use to control the program that will get Lightning McBot through the obstacle challenge course. You remember in about his second or third adventures of Lightning McBot, he turned around and ran. Well, we're hoping next time that things go a lot better. Okay, and here's what happens. Here's your remote. You notice you have a D key and an E key on there. I would like to have it that when you press D, it starts the program, and when you press E, it stops it. Now, I'll need some sort of program to run. At first, I'll do one that flashes lights and makes sounds because that's static, so that's a little safer. Actually, I have it where it actually has him move forward. Optionally, he can do light and sound indicators while he's moving forward or while he's stopped to indicate what he's thinking at the moment. I would also like to have it where I can restart the program. That will become handy because what we'll do is I'll have to take him out to his test track. Well, it's useful if I can run the program several times and make sure that how it's running. Okay, managing the project. First of all, safety. I'll have a simple program to start with. It just turns the lights and colors and makes sounds. That way he's not actually moving. Once I get where I think the program's actually working, I'll have it where he actually moves. I will save this code out to reuse it in subsequent programs. I have here a little toolbox. Most programmers have a little toolbox of code they've already written, and they reuse it and they splice it in as necessary. Okay, while I manage this progress, I need to understand that I need to make videos on it, and I need to schedule time to test it. Okay, when I build the program, I will build a simple light flash program and test it, and I expect it to flash as expected. Then I'll start adding the stop and start features and testing them as we go. Then I'll add the feature to detect an obstacle and stop moving. Okay, the overall test to make sure that you can start and stop the robot, that you can run the program if you like. Make sure it does stop for an obstacle. That's nice since it's an obstacle avoidance program. And also make sure that E will stop the key E will stop the robot while it's moving, so that if something goes wrong with the program, I can stop the program. Okay, that's enough theory. Let's go write some code.